Hello, everyone, and welcome to AWS Made Easy, episode number 9. And today we are very fortunate to have Nathan Peck with us. And
Hello.
Nathan is a senior developer advocate with AWS, and he's focused on CDK and containerization technologies. So how's everyone
Welcome
today?
to
We
the
also
show,
have
Nathan.
Rahul with us. And thank you, Karen and Marissa, our ASL interpreters, for making this live stream more accessible.
Hey, Nathan,
How
how
is
are you
everyone?
doing?
Doing
Doing
great
very
today.
well
It's a good start to the week after a long weekend, and ready to get back into the tech.
Yeah, I hope everyone had a great 4th of July. And Nathan, you're in New York. How are the
Yes.
celebrations there?
Very noisy.
We can contrast that with Seattle, where Stephen is at the moment.
Oh, we had a really nice show over Lake Union, and then had a few unofficial extensions to the show that the kids appreciated. Leave it. It was
Sounds
nice. I couldn't guess for better weather. After the wettest spring on record, it was nice to have a perfect summer evening for the 4th.
Yeah,
and the
here
wet
it is
spring means
different.
less risk of starting a fire by accident.
Nice. Here I just returned back from Seattle. I'm in Dubai at the moment this week, and just recovering from jet lag. So those are the updates from here. So awesome. We have a really packed set of conversations to have today, all around CDK. So I don't want to take away too much time from that. Just quick set of instructions, Stephen, for the audience.
Yeah.
Where they can post questions and how can they ask?
So we are, again, please, for the audience, please ask questions. We are on LinkedIn, Twitter, Twitch, but we ask a question on any one of those platforms, and we'll try to get to it in close to real time as we can. And yeah, we're just excited to have you. And yeah, let's dive right into it. So Nathan, first, just give us some of your background and tell us about yourself. What's been your trajectory with cloud and AWS, and how did you wind up as an advocate for CDK and containerization?
Yeah, sure thing. So I basically came from the startup world. I straight out of college ended up joining a startup, and I've always been from the very beginning very focused on building things efficiently, quickly, because I worked for small companies that are trying to hit product market fit. Most of the time, the small startups I was working at did not have product market fit. They didn't have enough customers, and so their main focus was how can we build features faster and deliver results faster to try to figure out what our customers even want in the first place, so that way they'll come and join. So from the very beginning, I've always been very focused on what is the technology I can utilize which helps me to build more efficiently, deliver to the cloud, and deliver a production ready application quickly and efficiently. So that's led me down the path, obviously, to AWS, first of all. Less resources and less infrastructure to manage overall. Eventually to infrastructure as code and containers. All three technologies, cloud, infrastructure as code, and containers, being things that helped me to build better and faster and more efficiently with less wasted time. And so now that eventually led to me as an early adopter of ECS and writing some blog posts about it and being sort of a star customer. I transitioned from that role into working for the container services team at AWS to help them make the product better and evangelize the product to other folks who could also be trying to build out their startup, trying to build something big and exciting, but need help trying to figure out how they can build it faster and more efficiently. So kind of taking my learnings from 7+ years of startup world to other folks who want to build their startups.
Also, well, thank you for that, and thank you for the background. It's really a neat trajectory of coming from the startup world and then seeing how to actually make the infrastructure to enable these other companies, whether they're startups or Fortune 500s or anything in between, they can all use this this great AWS infrastructure that we have access to. So going to the focus of our show, CDK. So what's the elevator pitch for CDK?
All right, so my elevator pitch for CDK. Well, first I should probably mention what CDK even stands for the folks who aren't super familiar. It stands for AWS Cloud Development Kit, and basically it's a hybrid between an SDK. If you're a programmer, you're familiar with Software Development Kit. The idea that you can pull this library in and it provides you with an API on top of for accomplishing something. And it is essentially an SDK for the cloud. And it allows me to provision, create, configure cloud resources using a programming language I'm familiar with. And that programming language, in most cases, will be the exact same programming language that I use for building my application. And so the elevator pitch for it is this piece of software enables my engineers to actually build and deploy cloud infrastructure without needing to have one specialist who only knows how to do cloud and one specialist who only knows how to do application development, and very little cross collaboration between those two, other than let me pitch this application over the wall to the cloud guy or the cloud gal, and then they say, oh, well, your application isn't working right, and back and forth, right? Instead, we can have one combined team which is working on both, and that really enables some very fascinating development practices.
So that brings up an interesting question. Then AWS has always had the SDKs to deal with and interact with the cloud. Like in Python, you've got the Boto 3 library it's so extensively used by anyone who uses Python, for example. Why build something on top of something like CloudFormation, which feels now completely separate and disconnected, instead of building like another layer of abstraction over Boto 3? Or the other libraries in languages like the Ruby one or the Node.js one. Like, we already have a whole suite of those. Wouldn't it have been easier to build a layer of abstraction on top of that rather than go down the path of CloudFormation? Like, what brought about that decision to go one way rather than the other?
I think this is where it comes down to difference between declarative versus imperative. So even though Cloud Development Kit is based on an imperative language, it's actually a declarative framework. And so I guess first I should explain what the difference is between declarative and imperative. So the idea behind imperative is you write commands. So you say, I would like you to create this resource. I would like you to update this resource or delete this resource. And so when it comes to creating infrastructure, that turns into a boilerplate script, which anytime you need to create or update something, you have to first check to see whether that resource exists. If it doesn't exist, then I create it, right? If it already exists, I check to see whether it matches what I want to have existing. And if not, then I update it. And then I check to see if it exists. And if it was not supposed to exist, then I delete it, right? So you have this very common boilerplate pattern you have to iterate over for every single resource. So what if there was a better way to describe this, right? And so the way I think about it is just a shopping list or an inventory list. So I create my shopping list of all the resources I want in the cloud, and I hand it off we call this declarative style. I hand it off to a declarative platform and say, here's my declaration of what I want on my shopping list. And you go out and make that a reality. I don't care whether you're creating, I don't care whether you're updating or deleting resources. Just make the reality match my inventory list. And so that's where CloudFormation adds a lot of value there, because every resource has complexity as to whether or not the resource is ready. What pieces go into figuring out whether that resource has been created fully or created successfully, different status codes that may happen, failures. So CloudFormation hides as much of that away from you as possible. It allows you to just give an inventory list. So you say, I would like this RDS database with this version of MySQL. I would like this S3 bucket. And so CloudFormation says, I'll take your inventory list, I'll make all these things a reality, and then I'll give you back a final status, which is whether or not it was successful or not. So that saves you a lot of boilerplate writing code to manage, like, well, what happens if there was a failure at this MySQL? What happens if there was a failure at this S3? And it allows you to distill everything down to pass off the inventory list, get a result back.
Yeah, but I'm not sure if that addressed the problem of, like, I assume that CloudFormation itself was written using a lot of the underlying
Oh,
API,
yeah.
right?
Yeah, for sure.
So it's just a question of
so,
exposing, because part of it feels like a little bit of a hodgepodge where there are fundamental differences in the declarative versus the imperative, programming paradigm. But then when you're literally offering the imperative paradigm on a platter with something like CDK and you're saying, hey, this is the way to go, then why not base the imperative stuff on other underlying imperative SDKs rather than CloudFormation? So that was something that always confused me about it.
Yeah, so I think number one, it's a question of familiarity. Like, a lot of people are already familiar with CloudFormation, right? And there is something good about having a declarative layer in between, which you can fall back on if you do want to export out of the system. If you don't want to use CDK anymore, you can always fall back down a level to CloudFormation. I also think, just in terms of building something like CDK itself is already a tremendously complex project, right, involving many 100,000 lines of code. I don't think anybody wanted to sit in there and rewrite CloudFormation as well as CDK, right?
Got it.
So the way I see it is the layers kind of build on top of each other, just as we have operating system layers that built on top of lower level kernel and then higher level tooling, higher level tooling. It's the same for infrastructure as code in this case. CDK is built on top of underlying tooling, and that allows CDK to improve as underlying tooling improves. So, for example, now CloudFormation has drift detection, which, by the way, did not have when CDK initially launched. But because that drift detection was added in, there's now the ability to seamlessly within a CDK application get notification out of CloudFormation when the real state of your resource has drifted from the reality of what you wanted in your CDK stack. So I think building on top of existing tooling, once again, it's more efficient, it's faster, it provides that confidence that even if I'm not wholeheartedly sold on CDK, I do know that there is an underlying CloudFormation that I can fall back on if I decide, I'm kind of done with CDK for now. Let me start using the CloudFormation directly.
So I put as a background slide for everyone just the workflow of how CDK interacts with CloudFormation. So the idea is that you write code using the CDK library, and then there's this synthesis step, which will then generate your CloudFormation templates, which then get sent to CloudFormation to do the deployment, and then you get handed back resources which may already exist or may have been newly created or may have been changed to reflect a new desired state. So is that's an accurate summary? And you're saying the idea of, rather than having CDK kind of skip this step and deploy to the cloud directly, is that, well, so much work goes into CloudFormation that you can almost use that as your assembly language.
Yeah, and not only just using it as an assembly language, but also I think it allows you to have a snapshot which is sort of set in stone. Because, as you mentioned, you're writing code in a imperative language at the CDK level, which is totally fine. It provides a lot of shortcuts, and we can talk about the benefits of that later. But the benefit of a declarative language is that it is very predictable. And so with CDK, one of the things I can do is I can synthesize my stack into the declarative artifact. And then that declarative artifact is now, the inventory list is set in stone, it's baked in. And I can then redeploy that as many times as I want without ever rerunning the imperative code again. So if you think about it as a pipeline, the imperative code is used at one stage, but then the output of that is the declarative thing, which is set in stone. It's locked in. and then that pattern then gets deployed as many times as necessary across as many AWS accounts that you might have. So there is a benefit to having the two-stage approach there, where the declarative artifact, it won't change, whereas imperative, each time you run it, maybe there's a logic in there that uses math.random, right? And it randomly chooses whether or not to create a resource. Like imperative code could be doing anything at all in there, right?
True. So let me ask you this. So without a doubt, I think from our use of CDK and our experience with CDK, if you compared it with something like CloudFormation, it's night and day, right? I mean, there's so many decisions that have been made so much simpler because you have CDK now to do all these standard patterns. There are some abstractions that are available. There are all of these libraries that you can literally just import and get started with right away. So tons and tons of value out of having something like CDK being available to you, without a doubt. The flip side of something like CDK is that it kind of automatically generates this CloudFormation that you might not be familiar with, or you don't know how it got generated. Or sometimes there's just so much CloudFormation in there that you feel like you need to then master that generated code. And I have never known generated code to be easy to understand, easy to read, easy to grapple, even if the claim is that, oh, you can just reuse all that, the CloudFormation stuff as is without ever having to, rerun the transpiler of sorts.
Mm-hmm.
So how many customers have you come across who end up going back to CloudFormation generated from CDK and saying, okay, now that's my standard, I'm checking that in to my source control, and that's what I'm going to run?
I don't think I've seen very many, because most people tend to get sold on CDK to the point where they say, okay, I don't really want to go backwards now. So it's kind of once you start using it, you're like, okay, this is amazing now. I like having the ability to fall back on CloudFormation if necessary. And in fact, from CDK, you can hook into the underlying CloudFormation and modify things directly, even if it's not supported inside CDK. So generally what I end up seeing is folks who do have that deeper underlying CloudFormation knowledge and do want to do the fallback, they end up using the CDK methods for manipulating the underlying CloudFormation from their CDK stack, rather than necessarily doing a full export, locking in their CloudFormation forever, and then just manipulating the CloudFormation directly.
Got it. But do they express concern about not knowing what CloudFormation gets generated, or not being able to understand all the underlying, like simple things like IAM roles, right? I mean, I would,
yeah.
Like,
so I think
that
that's
for me becomes one of the big areas of concern. Like,
yeah, I get what you're going for there, and let me explain how I think about this. There are a lot of tools out there, and even the AWS console, which automatically create IAM roles for you, which automatically create resources. If I'm clicking around the AWS console, in some cases I click a checkbox, or I click next on a dialog, and behind the scenes, 3 different resources got created, including a magical IAM role, right? So, and if you're using something like AWS SAM, if you're using AWS Copilot, if you're using any number of different tooling that's out there, is creating multiple resources each time you do an action. And a lot of people, they don't understand the underlying behind that either. So I don't necessarily think that CDK is worse than other tooling in that respect. In fact, I would say that the console, in many cases, is very confusing, because I've been in the boat previously as a customer, clicking around the console when I created my application stack manually, and then I've later wanted to create CloudFormation, and I didn't understand all the whole list of resources that was going to be necessary. I was like, wow, I didn't realize what the console was doing behind the scenes for me. I didn't realize that it had actually created this role and that role and tied these 2 things together. And oh yeah, it also created a security group for my load balancer. And I'm like, wait a minute, this was more complicated than I thought it was. So I think that fundamentally what it is like, people think about an API, and the way I think about it is if I'm creating my architecture and I have a whiteboard in front of me and I create service A and then I draw that line over to service B, it looks very simple on the whiteboard. And that's how people want to think about it. They want to think about simple top level concepts, but then underneath those top level concepts is a list of different resources and settings that are necessary in order to make that top level concept between A and B work. And no matter what tooling you use to accomplish that, whether it's CDK, the console, some other command line tooling, these are all abstractions and they hide away some of the complexity. But the advantage of CDK is that you can dig deeper into that underlying complexity more easily. Like with a console, it creates that IAM role, and I have to go in and manually hunt for it.
Yeah.
With CDK, I can type CDK synth at any time, output the template, and read through the list of resources to see that inventory list of everything that CDK wants to create. And so that actually helps me understand a little bit better that when I make this change, I see this change in the infrastructure as code. When I add this one line in CDK, it adds these 10 lines of CloudFormation.
So effectively, there is a fundamental level of complexity just based on what the nature of what we're doing.
Yeah.
And it can get hidden by different tools to a point, but then eventually at some point you will have to know you'll have to understand the underlying system to some extent, at least to be able to play with it. And whether that's, I don't know, using some framework that compiles to JavaScript, eventually you do need to know some JavaScript. And if you're using some framework that compiles to CloudFormation, you'll have to, at the time being, you'll eventually have to know some CloudFormation to be able to effectively use it or customize it. And I can imagine that at some point in the future, there can be users of CDK who would never touch CloudFormation, which would be a neat place to be. Let's take a quick 30-second break.
Potentially possible, yeah.
Let's do a quick 30-second break, and we'll come back and let's talk a little bit about the CDK patterns for containerization. We'll just be right back after a word from our sponsor.
Is your public cloud riddled with cost and complexity? CloudFix is here to clean that up. CloudFix focuses on cost savings for your AWS environment by finding and implementing fixes that continuously save 25% off your AWS bill. Too good to be true? We've helped organizations save millions across 45,000 instances. Visit cloudfix.com to schedule a free assessment and see your yearly savings.
And we're back. So you talked about part of your expertise being CDK, but we wanted to kind of bring in your other background in containerization. Can you tell us about some of the patterns of how CDK can help with container-based deployments, or what patterns have evolved or have been designed to deal with this?
Yeah, sure. So I think that containers in particular are a place where you will see CDK shine as a development tool. So one of the challenges with containers is that it's a multi-stage process where there's different pieces of tooling that are required. In particular, you have to build your container first and then push it up to the cloud. And then you can create your definition for how you want to actually run that container in the cloud. So where CDK helps is it turns all of this into and bridge it into something that is consistent. It bridges this gap between the local development experience and the remote cloud infrastructure. I can have CDK both build my application for me automatically, manage creation of a registry for uploading my container to the cloud, automatically push it, and then run that image. And so from my perspective, I just have a directory full of code, and I have a CDK statement that says, build this directory of code as a container and ship it up to AWS Fargate. And the rest of that whole pipeline from taking the code into a container to shipping it up to the cloud to running in AWS Fargate is all handled by CDK code and then infrastructure as code under the hood with CloudFormation. So I think it makes the pipeline a lot smoother and easier to integrate as compared to having a separate tool for the infrastructure as code and a separate tool for maybe it's a bash script or something along those lines for writing out a list of commands to run one after another in order to actually build my application and push it up.
I was literally thinking about, I've had that exact scenario where I thought, okay, I want to do something with containers. I thought, okay, I've got a bash script saved with my AWS ECR commands because I hadn't done the work to fully bring it into one integrated system. So, okay, yeah, exactly right. I'm copying and pasting EC commands from a text file that I've cargo culted around with me. So there's a much better way of having it completely consistent. I like that a lot.
And I think the
But
other,
isn't
the
it?
other
Sorry, I'm just going to pile on that, but kind of try and bring in a slightly more opposing view. Today, when you look at the code, right? I mean, code has the same problem where you need a build file that says what you build, and then you've got a build, whether it's Ant or whether it's, your npm build or whatever. You have all these targets, or even just a simple make file. You might have a make file that has 5 different targets: one for build, one for deploy, one for whatever other operations you might build, package, deploy. Those are all your standard targets that you have pretty much across languages these days. And then now you've got other kinds of packaging, like you create a Docker file that describes how you build up that container and provide all the definitions over there. So does this add more complexity? Because now you have one other place where you have configuration that talks about how you do something, and it's a different target now. It's not really part of your regular code and your build. It's one more thing that's different in your code, one other place to go figure out how to deploy something, versus, like, by the way, even when I use CDK, what are the practices that I use, irrespective of what CDK commands I might have under the hood? My make file, invariably, the deploy in my make file has a CDK command in there. Okay, so it makes it easy for me to go to one place where I have all of the commands, whether it's build, whether it's deploy, whether whatever. People are not running around in different tools trying to figure out how to get the basics done. So it's always a make, build, make, deploy, those kind of commands. Are there any best practices around that, around how you organize your code for one more tool that's getting added now to your setup?
Yeah, so I think I'm actually working on a blog post on it, and I wish I had got this blog post out last week. There were some blockers though, but basically, I addressed that question of like, how do you use containers as part of your development process? And I think the point or the point you were making about all these different tools is a valid point. However, containers, when used properly, make it so that there is one standard command for building your application. No matter what language you're using, if I'm using Python, maybe I have a pip install, right? If I'm using Node, I have npm install. There's a variety of different commands, but there is one format now, which is Docker file, where I define those language-specific build steps and language-specific commands. And then my application is always built using the exact same command, which is Docker build, right? And so I think what the places where the layers of separation of concern are is Docker file down contains all the things specific to building my particular language framework. Maybe if it's C application, it's compiling the garbage collect, compiling with GCC, right? Or Go app is compiling, right? It could be Ruby. No matter what is language specific, that's in the Docker file. Then from that area up, Docker is responsible for the packaging and collection of those resources and turning it into a tarball, basically, zip file. And then CDK is responsible for uploading of that to the cloud and launching it as a resource on your AWS account. So there's 3 very specific stages that it goes through. And the interesting thing about it is now I don't actually need any other tooling. I don't actually need the make file, actually, because potentially I have a make file, but that's happening inside the Docker image. I don't actually care about make anymore. Make doesn't even exist on my machine anymore. In fact, when I do the Docker build, it pulls down a Docker image on the fly, which contains make in my ideal version of GCC, C++
Right.
compiler or whatever, does the build inside the container, right? So I don't even actually have any development tools on my laptop anymore. Everything is on the fly inside the container. And so it makes for a very interesting process where everything is very repeatable. I can do that build very easily on any computer because I don't have to rely on an engineer having a specific set of tools with the right version on their particular developer laptop. So I think that's what I would describe as like the best practice and where that breakpoint comes between tooling that is containerized and tooling that is not containerized but running on your host for the purpose of uploading stuff to the cloud.
That makes a lot of sense, but it also brings up a legitimate concern that I've heard from a lot of my teams and also externally, which is given that CDK is very much a client-side setup, written in Node, the versions of CDK start, coming into question and concern. Like, if I'm going to use CDK today, 6 months down the line, here's another piece of code and the dependencies and stuff that I need to kind of make sure I have working all the time. And with some of these node-based applications, because all the dependencies keep changing so frequently, node versions start becoming a concern. 6 months down the line, is this stuff going to work out of the box or not? If I don't keep maintaining it constantly, and if I've not done a new deployment for 6 months, I don't know whether my stuff is going to keep working or not because of this new dependency. So how do you guys think about it? How do you guys address it for AWS customers in general?
So I would address it the same way I address that for my own application, which is to containerize it.
Okay.
So it is entirely possible to create a container out of any application that you want to, including CDK. And in fact, CDK development, when you're actually developing on CDK, there is a containerized process for that. If you read through the contributor guide. So the cool thing is you can actually package up a specific version of Node runtime, specific version of all the packages, specific version of CDK, and turn that into a repeatable, reproducible thing that's always going to run the exact same way, and then use that as part of your development process. So now it is referencing via Docker volume, it's finding your infrastructure as code, it's running it inside the container, and now it's communicating up to the cloud. So I keep coming back to containers because that is a tooling that I've used many times to solve this problem for my own application. It can actually solve it for any application. And I think in general, though, the main concern with things breaking over time in the Node ecosystem is not that I run this today and then 6 months from now it doesn't run anymore, because it'll generally still run. But it's more that different underlying packages may discover security vulnerabilities and stuff like that. So there's a little bit of what we call a package rot over time.
Yeah.
Now, ordinarily, that's very concerning for a production-facing application that receives public traffic, because if one of those packages has a vulnerability, that's very problematic. Somebody could be exploiting it and breaking into my web-facing application and hacking it. But for a sort of back-end tool, which in this case, CDK is only running on my local host, and if I really do it properly, it's only running on a CI/CD server, an actual deploy pipeline server like Jenkins or AWS Code Build or something like that. That's sort of behind the scenes. It's behind the firewall, so to speak. It's not receiving anything from the public. The only person who's using it is my own developer. And if I have a concern about my local developer sort of exploiting the system and hacking in, I've got way bigger problems.
That's a very we call adversarial environment to plan for.
Yeah, so exactly.
So to summarize, you're saying, well, just like everything else, just freeze your setup at a point in time. Now, of course, little pet peeve. if you're going to use Docker, don't always just say Ubuntu latest or whatever, because then when you rebuild that container, but pin it to a certain version, pin your node to a certain version, and that way, since at the end of the day, what you're using CDK for is to make a CloudFormation template, and everything. That's the only output that's going to come out of it that you really need. So it doesn't matter if a certain version of a certain dependency gets old.
I just pin everything and like keep everything static, right? And then if there's security vulnerabilities in underlying packages, it's okay. I just set a task every 6 months or a year or whatever to be like, okay, let's update all the pins to the latest version, make sure that things still work. And but I don't do like dynamic updates on my CDK version that frequently.
Yeah, that makes sense.
It makes for such a great use case for dev spaces or code spaces, where once you have your containerized dev environments, like you shouldn't have to change that. And yeah, it makes for a great marketing pitch for both of those.
Yeah.
Well, let's take another quick break, and when we come back, we want to talk about. We have actually got a question that we want to address on best practices. So let's come back in 30 seconds here.
Public cloud costs going up and your AWS bill growing without the right cost controls? CloudFix saves you 10 to 20% on your AWS bill by focusing on AWS recommended fixes that are 100% safe with zero downtime and zero degradation in performance. The best part? With your approval, CloudFix finds and implements AWS fixes to help you run more efficiently. Visit cloudfix.com for a free savings assessment.
All right, we're back, and we've got a question from the audience by Gaurav, so I'll put it up on the screen here. What are the best practices to use CDK across multiple accounts that have shared resources? And we certainly have a couple of accounts under our belt here. So, yeah, what's the way to do this? Rahul, can you give us an idea of the magnitude of the accounts we're dealing with?
Yeah, I mean, in our world, we are dealing with over 40,000 accounts across all of our portfolios. And so that, of course, is a big challenge. But just to take a very specific and concrete example, right? I mean, when you invariably, you want to, because you have a large number of resources deployed across multiple different accounts, one of the common practices that we had historically, and we're still trying to figure out how to get it working in the CDK world, is we would design specific IAM roles and specific IAM, resources, whether they be, groups or policies or whatever. We would create all of these as common, resources. We'd set it up once, and then we'd start mandating that everyone use the same policies across all the Lambda functions you deploy or across, whatever other resources that you are provisioning. Now, we're still trying to figure out what the best way to do this with CDK is, because once you've created a set of IAM roles and resources with CDK, because this is more because CDK is more driven towards synthesis time decisions, it becomes really hard to leverage these common resource pools or these common resources across your CDK unless you start hard coding a lot of these things. What generally is a best practice to manage this kind of a setup? Or is it an uncommon setup?
Yeah, so I think there's a couple different ways to think about it. I think the first way that to solve the particular problem that you're mentioning, it would be the idea behind CDK is that you can create your own custom patterns and custom constructs, such as in this case, like if you want to create an IAM role specific to a Lambda function, you would create my company Lambda, right? So you're not just using the base Lambda, you're creating your own special, customized, private labeled, if you will, Lambda. That's my company Lambda. And by doing that, you're able to package up the definition of that particular IAM role and that particular Lambda and settings for it. Maybe there's a specific timeout that you want to give the my company Lambda or something along those lines, or specific environment variables. And you then distribute that construct as a pattern for other teams to utilize. And if you're familiar with the Node.js ecosystem, the idea is you just turn that into an NPM package. And now other people can pull in that NPM package and they can use it and you have central management. Provided they don't pin their versions on a really old version, right? If they have like some flexibility in their versions, you can now update centrally the My Company Lambda pattern with a new IAM role, and that rolls out the next time that they actually make a change. So it depends on whether you want to have true sharing of resources or whether you just want to have sharing of configuration, and central management of configuration. I couldn't really tell from the question whether the original question asker was talking about more about sharing of configuration or actual sharing of resources. I
think this is more sharing resources.
Yeah.
Sharing configuration is fairly straightforward.
Yeah.
Because it's time and therefore configuration is not that complex. But I think sharing resources that are already deployed, that becomes the complex part, because synth time, I mean, other than hard coding, it feels hard to do this at synth time.
Yeah, so I would never share an IAM role, for example. Every AWS account should have its own IAM roles. But I do think there's a place for sharing resources that are over the network. So, for example, you want to create a private link between account A, account B, and you want to say there's a shared database, and this account and this account both utilize this, or this service can talk to this other service over private link. So I think this is where it goes down to defining the networking rules. And one of the cool things about CDK is that it is multi-account aware. You can build in an understanding that this stack is in this account and this stack is in that account. And the nice thing about it is, because it is an imperative language, you can build in higher level methods, such as saying construct.connect to construct. And because I've defined everything with CDK and I have an imperative language there, I can introspect the stacks for each construct. And I can say, oh, your construct is actually in a completely different account in a different region. Therefore, I know I'm going to need a VPC link. I'm going to need a transit gateway, right? And so when the connect to method is called, I can choose to create these resources on the fly as part of that method using inside my imperative code. Now, if the two resources are in the same account, it becomes much easier. Now I can look at it and say, oh, you're actually both living in the same VPC. All I need to do is create a security group role. So you have one method, one standard method, which is called a.connect to B, and the method can do different things based on the broader understanding of where those resources are living, whether they're living in different accounts, different VPCs in the same account, or even the same VPC and just behind different security groups. So that's actually one of the powers of CDK, is the ability to create these higher level methods that do essentially magic to create different results based on the setting.
Got it. Now that makes a lot of sense. Let me jump into a slightly related question. But when I think about tools like CDK or Terraform or Pulumi or CloudFormation, I think of those tools falling in the resource lifecycle management set of tools, where fundamentally you're doing three things. A, declaring what resources you want. B, deploying those resources. C, either continuously or at some interval, figuring out the state, or you are maintaining state of some kind, where you got state in the cloud of your resources, and you got your declaration of, your bill of materials or bill of resources that you wanted, right? And then keeping those two things in sync. Especially since we were talking about containers, Kubernetes kind of also falls in that category, and it takes a very different philosophy around lifecycle management of containers. They do a version of, or a very contorted version of a lifecycle management thing for AWS resources, where you could do CRDs for all kinds of different resources. You use the same control plane, but you can deploy an S3 bucket, or you could go deploy whatever else, and it kind of operates in the continuous loop. So it's just a completely different perspective of how to tackle this problem. And I think we are still at the initial stages of understanding what is, the right way to do it. Things are still evolving across these different perspectives. Do you mind spending a couple of minutes shedding light on how you think about the differences between these different ways of tackling this resource lifecycle problem?
Yeah, so I think the main difference that we're seeing here is the difference between push-based and pull-based. So Kubernetes is designed for a pull-based control loop where the custom resources are constantly comparing the actual state of the resource as created on your AWS account to the intended state as described in your local etcd cluster.
Yeah.
And what you can do is have a custom resource, and this gets into like the GitOps approach. GitOps, they're sort of the purest approach, which is I don't do any pushes whatsoever. I actually have a controller running inside my Kubernetes cluster, and it pulls in configuration from the Git repo periodically and can actually notice when there are changes, and then it kicks off an update and creates resources on my account. I think CloudFormation is designed in the opposite direction. It's designed to be push-based. So CloudFormation will only make changes on your account currently when I actually issue a CloudFormation update or CloudFormation deployment and kick that off. So if there is another change that happens outside of the understanding of CloudFormation, that won't actually be reflected or rolled back, whereas Kubernetes can actually roll that back. So I think that's the main difference. And I think we do see a little bit of complexity and mismatch between these two models, in particular when it comes to resources like ECS services, which have a desired count for how many containers you want to roll out. Yeah. But that desired count is also itself mutated by ECS as the service scales up and down. We're seeing more traffic than ECS. Autoscaling kicks in and increases the desired count, which increases the number of tasks, and vice versa, it can scale in. Well, this desired count is no longer a static thing. It's something that increases and decreases throughout the day. So CloudFormation's approach to that is the way you handle that, you don't hard code a desired count into CloudFormation stack, because if you did, then every time you did CloudFormation deployment, it would actually roll back your auto scaling. Your thing could have scaled up to 20 tasks, but it'll scale you all the way back into 2 because CloudFormation doesn't know, right? So CloudFormation's approach is leave out the desired count. Don't specify a desired count at all, and it'll just use the existing value that's already there, right? So CloudFormation.
But isn't that a Kubernetes construct anyway? Because in Kubernetes, you have 3 ways of controlling the number of containers. You have the min, you have the max, and you have the desired count. Mm-hmm. You can basically use those as your control levers to decide how many containers are getting launched.
Correct.
And if you want a specific number, you always use desired count or the expected number of containers. And then if you want it to scale, you set the min and max to give it bounds, so that you have some control over how many containers you want at a minimum, or whether you want to have an upper bound on the number of containers it launches and doesn't go out of control that way. So, but that's more a common pattern of control for auto scaling versus non-auto scaling, right? It's not something that's specific to CloudFormation or CDK.
So that was what I was getting to, though, is that CloudFormation and CDK is approach to handling this type of property, which is dynamic and changing inside of the control loop, is to say we don't want to know about that at all.
Got it.
Leave it out, right? So I define everything else using CloudFormation and CDK, but I don't define the desired count, because the desired count is dynamic and it's increasing and decreasing automatically. Kubernetes is different because the infrastructure as code is actually stored inside of the control plane, and there is a back and forth where the actual autoscaler updates the desired count inside of your infrastructure as code definition, which then causes it to roll out. So there's a much tighter back and forth integration inside the Kubernetes control plane compared with CloudFormation, which does not currently have the ability to understand that there is this other thing like the ECS control plane or the Kubernetes control plane, which is mutating things outside of a CloudFormation deployment. So that is the fundamental difference there is that I, in some ways, I like the Kubernetes model a bit better, where everything is much more tightly integrated between the controllers and the infrastructure as code description. On the other hand, I do think that CloudFormation produces very reliable results because things only change when you do a deployment. With Kubernetes, there's a pattern of having mutating admission controllers, different mutating hooks that kick in and decide whether or not they want to change your pod before your pod actually gets placed into the cluster, right? So what can actually happen is you pass off a description of what you would like to be created, and that thing actually has changed behind the scenes, and maybe you update a controller and things will change inside of your cluster and change inside your infrastructure as code because it's no longer a static thing. It's something that is dynamic and updates. So really it comes down to the trade-off there. Do you want to have your infrastructure as code be something that can change after the fact, or do you want it to be a set in stone static thing which only changes when you specifically say do a deployment?
And you're saying so in other words, it's much easier to reason about the state of a CloudFormation deployment than the state of a Kubernetes cluster. If you're looking at everything that goes into it, the Kubernetes cluster could change based on things that happen at runtime much more flexibly, which is both good and bad, depending on what you want.
Yeah. So it's a trade-off as to which you prefer in that model. And I do think that in the ideal world, there would be an option to have both, if you will, and be able to say there are some things that I don't want to be changed at runtime. There are some things that I don't mind being changed at runtime, right? And so I think as the technology progresses, we're going to see more of a melding of the two models. Right now, it's two very conflicting ways of thinking about infrastructure as code as a dynamic thing that changes at runtime and as a completely static thing that doesn't change until I say to change it. And I think in reality, there are some resources that you would like to change and be dynamic. There's some resources you would like to be very static, like your database, for example, or something like that. And so there is a conflict there and a sort of mental model, and that will gradually resolve over time as we figure out which resources go in which bucket and how we want to define and lock some things in.
So just talk about the push and the pull, or those two different approaches. It brings me to the other common complaint that we experience with CDK, which is the slowness of, redeploying resources or just doing a small update. Like if I had, loads of stuff that was, deployed as part of my original CDK, and I literally just needed to change one Lambda, a big chunk of the wait time that happens in my CI/CD is invariably the fact that the system is just literally trying to detect drift, syncing all the data down, figuring out what has changed or not changed across all the resources, running through all that computation, figuring out what needs to be updated, and then finally doing a little bit of an update, which, we've got CDK deployments that, in our continuous build system where the build and deployment, when I talk about deployment, I literally mean uploading a Lambda function or something like that. That might take a grand total of like a minute, while the CDK operation could take anywhere from 20 to 30 minutes. That's not uncommon to have. And when you see something like that, you start thinking about why couldn't we optimize a lot of that by having a more continuous, at least sync of state, where you're not trying to recreate or, redo all the state over and over again.
Yeah, I think that's a good point. I would say my answer to that is, number one, I agree. I definitely wish CloudFormation was faster. I wish CDK was faster in some respects. I do think there are solutions to the problem, though, and it mostly comes down to more granular usage. CloudFormation is not designed to be used with really large stacks. And CDK, unfortunately, makes it really easy to create a gigantic stack. It's very easy. It becomes very easy to manage, hundreds of resources potentially, right? And create a huge stack. But the reality is it's still actually to your benefit to create micro stacks where each stack is maybe one Lambda and its DynamoDB table that it talks to. And then the other Lambda and the other resources are in a different stack. And what that allows you to do is have extremely granular CDK deployment. So if you say CDK deploy, this particular stack by name, that's probably not going to take 20 or 30 minutes, because it's only deploying a small piece of the stack independently of the rest of it. And so I think it comes down to the usage pattern. And this is something where maybe there's not enough documentation on best practices of how to sort of break things up. And even a lot of people don't realize how easy it is in CDK to create dynamic references across stacks. Normally, if you're hand coding CloudFormation, that's very challenging. And if you have a resource in one stack and you want to reference that resource in another stack, you have to create an import, you have to create an export, you have to do this and that, right?
Yeah.
And so it's scary. People say, "Oh, well, I'm just gonna put everything into one stack because that's easy, and I know the references work really easily." Well, CDK is the opposite story. Because CDK creates the exports and imports for you automatically, it actually becomes extremely easy to break things up into a ton of microstacks. Like your application might have 100 microstacks in it, and those stacks are sharing resources across stacks with automatically created and managed exports and imports that CDK does on your behalf. And now you can deploy one small slice or one small piece of your overall stack much quicker and much easier than waiting on the entire CloudFormation stack deployment.
That's actually a really interesting idea. Hadn't thought about this one, but how does that work when you have a single repository which has, let's say, 10 different microservices? You do define all these different stacks, but when code changes, let's say I had an API, right? I had 10 different APIs. They're all different microservices. They're all a different microservice each. I would have one code base that manages all of it. It packages up the same container. It's just that the endpoints differ depending on which API I want to call as part of that particular microservice. So even if I create 10 different stacks as part of the setup, when I run my CI/CD, the stack that needs to change is going to be a function of the code that changed.
Yeah.
And there's no simple way of mapping that. You basically run everything and say, hey, just make sure that whatever deltas have shown up now as part of this new packaging all get reflected accordingly. You're still going to run into that problem of syncing all the stacks because it's part of the same repository. It's not a completely different repository. Now, if you had, 10 different repositories, one for each microservice, great, makes sense.
Yeah, so CDK solves a little bit of that on its own. If you do break your stack up into a bunch of microstacks, CDK will see that particular stacks haven't actually changed. And so it doesn't have to deploy that stack. It will only deploy the stack that has actually changed since the last time there was a deployment.
So CDK can diff your code locally, basically.
It's a little bit more complex than that, but every time it creates an asset, such as a Lambda function or a container image or something like that, it captures a hash of that local folder or that wherever that source code came from. And so if it sees that your code hasn't changed, then it knows that that asset hasn't changed, which means it knows that Lambda function hasn't changed, which means it knows that that entire stack or that entire slice of the CDK app hasn't changed and doesn't actually need to be redeployed. So it's a little bit self-optimizing in that respect. Now, the downside is you still have to actually do the synth of every single stack. And so if you do have a particularly large deployment, there's going to be, and when you initially fire off that CDK deploy command, there may be like a 10, 15 second wait while it synthesizes all of that code. And that can sometimes be a bit slow. So I think that's where it comes down to a little bit of external tooling. And it can be a little bit hacky, but there is tooling out there which can detect for a mono repo which paths inside of the mono repo have changed since the last git commit. And based on that, you can create an understanding of this path is tied to this service, which is tied to that CDK stack. You have to do this custom, by the way. It's not something that's like built into CDK, but it's similar to the way make works, where make says, if this folder doesn't exist, then we run those commands to create that folder, right? In general, it is definitely easier to do things with a micro repo rather than a mono repo. And that's the reason why I recommended earlier that sort of ideal usage of CDK is that you have an infrastructure team which creates an NPM package and then vends that out to other teams to consume. So now each smaller team has their own micro repo, which pulls in a CDK package from a shared central repo, right? And that micro repo, when it deploys, can utilize the shared patterns from the centralized source, but just deploy the limited number of things that it needs to deploy for that particular service. So that does also help with carving down the surface area. I'm definitely more of a fan of micro repos than mono repos. So that's a little bit where my bias comes in. But I do know it is possible to solve this problem. Like obviously Google famously has solved this problem, have all of their source code in one gigantic repository, as I understand. And it's because they have that tooling to understand for each commit, what is the surface area of which services actually changed, and then which commands I run for which service to actually make this change.
Yeah, I think there are a lot of very interesting packaging trade-offs that have to be considered. Like the minute you have 10 different microservices that have the same packaging, if you start doing a Docker build for it, then again you've lost, because the hash is going to be now for the Docker image that got created, and so your topmost layer, which has the code, is going to change. That's going to change for all your stacks, right? And that's going to kind of nullify some of the other trade-offs. So I think it does make for an interesting range of new best practices for how you lay out a lot of these things. We continue to learn from our experience of managing all these code bases and all of these microservices, but we'd love to collaborate with you going forward, Nathan, to come up with more of these standard practices and contribute to the CDK project as well.
Yeah, for sure. I love chatting with you all about CDK today, and I think y'all are doing some great stuff with it. I would actually love to hear more about the 40,000 accounts too. That's amazing.
If you stick around, I can give you a little more background on that. But thank you so much for coming in and sharing all of these really neat best practices and patterns. This is really wonderful. I think we're going to have call you back for another session, because
I'd love to come back and be a guest again and chat about other topics, whether it's CDK or containers or whatever.
Absolutely, we really appreciate that. Thank you. You definitely got our wheels turning about just different ways of structuring, the microservice. I know I'm thinking about different ideas of how to chop up these projects in a bit differently to leverage some of the advantages of that. So thank you for all the different ideas you've given us.
Sure thing. Thank you very much for having me.
All right. Awesome. Well, and thank you to our audience, and thank you again, Marissa and Karen, for the interpretation. And we will see everyone next week.
All right, I guess that's a wrap.